This video is about secant, cosecant, and cotangent. This is AP Precalculus topic 3.11. If you appreciate this content, please give it a like. Number 1. Let f of x equal 3 times the secant of x minus 2, and g of x equals 4. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of f and g between 0 and 2 pi? The intersection points will occur where f of x is equal to g of x, so we need to set f of x equal to g of x and solve. Let's isolate the trig function, starting by adding 2 to both sides. We get 3 times the secant of x is equal to 6. Dividing both sides by 3, we get secant of x is equal to 2. The reciprocal of secant is cosine. So let's take the reciprocal of both sides, and we will get the cosine of x is equal to 1/2. We can find the reference angle by asking ourselves the cosine of what is equal to 1/2. If you have not yet memorized these 9 trig values, pause the video and memorize this chart right now. Because the cosine of pi over 3 is equal to 1/2, that means the reference angle is pi over 3. The reference angle is the angle between the terminal side and the x-axis. Between 0 and 2 pi, there are 4 angles with a reference angle of pi over 3. These are significant because the cosine of any one of these angles will be some kind of 1/2. It's just that 2 of them will give us negative 1/2, and 2 of them will give us positive 1/2. In this case, we want cosine to equal positive 1/2, and cosine is the x value on the unit circle, and x values are positive in quadrants 1 and quadrants 4, the right side of the unit circle. So we will restrict ourselves to these 2 solutions. In the first quadrant, the angle with a reference angle of pi over 3 is pi over 3 itself. But what about in the fourth quadrant? Well, pi is right here, and looking at the reference angle, we can think of this as 3 pi over 3. Doubling this, we can think of 2 pi as 6 pi over 3. Therefore, this angle is pi over 3 less than 6 pi over 3, which is 5 pi over 3. And these are the x-coordinates of the 2 intersection points. Number 2, let h of x equal 5 minus 2 times the cosecant of x, and k of x is equal to 7. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of h and k between 0 and 2 pi? Let's set 5 minus 2 cosecant x equal to 7 and solve. First, let's subtract 5 from both sides. This gives us negative 2 times the cosecant of x is equal to 2. Next, dividing both sides by negative 2 gives us the cosecant of x is equal to negative 1. Cosecant is the reciprocal of the sine function. So if we take the reciprocal of both sides, we get sine x is equal to negative 1. The reciprocal of negative 1 is still negative 1. We can solve this equation by asking ourselves the sine of what is equal to negative 1. On the unit circle, sine is the y value, and the y values are equal to 0 here, positive 1 up here, back to 0 here, and negative 1 down here. So the sine of 3 pi over 2 is negative 1. So that's the solution. And this is the x-coordinate of the only intersection point. Number 3, let m of x equal 2 plus radical 3 times the cotangent of x, and p of x equals 1. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of m and p between 0 and 2 pi? We need to set 2 plus radical 3 cotangent x equal to 1 and solve. Let's begin by subtracting 2 from both sides. That will leave us with radical 3 times cotangent of x equals negative 1. We can isolate cotangent by dividing both sides by radical 3. That will leave the cotangent of x is equal to negative 1 over radical 3. Tangent is the reciprocal of cotangent. So if we take the reciprocal of both sides, we will get the tangent of x is equal to negative radical 3. We can find the reference angle by ignoring the negative sign and asking ourselves the tangent of what is equal to radical 3. We have memorized that the tangent of pi over 3 is radical 3. So pi over 3 is the reference angle. In this case, we want tangent to be negative, and tangent is the slope of the terminal side. So we will only consider the quadrants where the slope of the terminal side is negative, and that happens to be quadrants 2 and 4. What is the angle in the second quadrant that has a reference angle of pi over 3? Well, pi is right here, and we can think of pi as 3 pi over 3. Therefore, this angle will be pi over 3 less than 3 pi over 3, which is 2 pi over 3. Doubling this, we can think of 2 pi as 6 pi over 3. This angle in the fourth quadrant that has a reference angle of pi over 3 is pi over 3 less than 6 pi over 3. That's 5 pi over 3. So these are the x-coordinates of the two intersection points. Number 4. Let f of x equal 3 cosecant squared x minus 1 and g of x equals 3. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of f and g between 0 and 2 pi? Let's set 3 cosecant squared x minus 1 equal to 3 and solve. First, we add 1 to both sides. This gives us 3 cosecant squared x is equal to 4. We can isolate cosecant squared by dividing by 3 on both sides. This will leave us with cosecant squared x is equal to 4 over 3. We want to unsquare this, so we're going to take the square root of both sides. When you take the square root of cosecant squared, it just leaves cosecant x. When you take the square root of both sides of the equation, the solution will be positive or negative. So don't forget the plus or minus on the right-hand side. When you take the square root of a fraction, you actually do it by taking the square root of the numerator and the denominator separately. The square root of 4 is 2, and the square root of 3 is radical 3. Cosecant is the reciprocal of the sine function. So if we take the reciprocal of both sides of this equation, we get sine x is equal to plus or minus radical 3 over 2. We can discover the reference angle by ignoring the plus or minus and asking ourselves the sine of what is radical 3 over 2. Considering the 9 trig values which we have memorized, we know that the sine of pi over 3 is radical 3 over 2. So the reference angle is pi over 3. Between 0 and 2 pi, there are 4 angles with a reference angle of pi over 3. There's one in every quadrant. These angles are special because the sine of any one of these angles will give us some kind of radical 3 over 2. It's just that 2 of them will give us positive radical 3 over 2, and 2 of them will give us negative radical 3 over 2. Since we're interested in the values of x for which the sine is positive or negative radical 3 over 2, all 4 of these angles are solutions to the equation. In the first quadrant, the angle with a reference angle of pi over 3 is pi over 3 itself. In the second quadrant, we will think of pi as 3 pi over 3. Therefore, this angle in the second quadrant is pi over 3 less than 3 pi over 3, which is 2 pi over 3. This angle in the third quadrant is pi over 3 more than 3 pi over 3. That's 4 pi over 3. Doubling this, we can think of 2 pi as 6 pi over 3. So this angle in the fourth quadrant is pi over 3 less than 6 pi over 3, which is 5 pi over 3. So these are the x-coordinates of the 4 points of intersection. Number 5. Let h of x equal 5 plus radical 3 secant x, and k of x equals 3. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of h and k between 0 and 2 pi? So let's set 5 plus radical 3 secant x equal to 3 and solve. First, we subtract 5 from both sides. So that gives radical 3 secant x is equal to negative 2. Next, we divide both sides by radical 3. This leaves the secant of x is equal to negative 2 over radical 3. Secant is the reciprocal of the cosine function. So if we take the reciprocal of both sides of this equation, we have the cosine of x is equal to negative radical 3 over 2. We can discover the reference angle by ignoring this negative sign and asking ourselves the cosine of what is equal to radical 3 over 2. We have memorized that the cosine of pi over 6 is radical 3 over 2. So the reference angle is pi over 6. On the unit circle, cosine is the x value. And in this case, we want cosine to be negative. So we will only consider the quadrants where x values are negative. Those are quadrants 2 and 3. Looking at the reference angle, we can think of pi as 6 pi over 6. So the angle in quadrant 2 with a reference angle of pi over 6 is pi over 6 less than 6 pi over 6. That's 5 pi over 6. The angle in the third quadrant is pi over 6 more than 6 pi over 6. That's 7 pi over 6. So these are the x-coordinates of the intersection points. Number 6. Let m of x equal 3 plus 5 secant squared x, and p of x equals 13. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of m and p between 0 and 2 pi? Let's set 3 plus 5 secant squared x equal to 13 and solve. First, we subtract 3 from both sides. That leaves 5 secant squared x is equal to 10. Next, we divide both sides by 5. That leaves secant squared x is equal to 2. We can unsquare this by taking the square root of both sides. Be careful, when you take the square root of both sides of an equation, the solution will be plus or minus. So we will get secant x is equal to plus or minus the square root of 2. Secant is the reciprocal of cosine. So if we take the reciprocal of both sides, we get cosine x is equal to plus or minus 1 over radical 2, also known as radical 2 over 2. We can find the reference angle by ignoring the plus or minus and asking ourselves the cosine of what is 1 over radical 2. We have memorized that the cosine of pi over 4 is 1 over radical 2. So pi over 4 is the reference angle. Since cosine can be positive or negative, we will find solutions in all 4 quadrants. In the first quadrant, the angle with a reference angle of pi over 4 is pi over 4 itself. We can think of pi as 4 pi over 4. So the angle in the second quadrant with a reference angle of pi over 4 is pi over 4 less than 4 pi over 4. That's 3 pi over 4. The angle in the third quadrant with a reference angle of pi over 4 is pi over 4 more than 4 pi over 4. That's 5 pi over 4. We can think of 2 pi as 8 pi over 4. So the angle in the fourth quadrant with a reference angle of pi over 4 is pi over 4 less than 8 pi over 4. That is 7 pi over 4. So these are the x-coordinates of the 4 intersection points. The last 5 problems are calculator active. Number 7, let f of x equal 5.1 plus 2.3 cosecant of 0.4x minus 2. In the xy plane, what are the x-coordinates of the points where f of x is equal to 2 between 0 and 2 pi? So we need to set f of x equal to 2 and solve, but we can easily do this on the graphing calculator by entering the left side of the equation as y1 and entering the right side of the equation as y2. The solution will be the intersection point between these two curves. I'm entering the left side of the equation, and it's time for me to type cosecant, but there is no cosecant button. We do remember that cosecant is the reciprocal of the sine function, so we have two choices. I can either type in cosecant as 1 over sine like this, or I can type in sine like this and raise it to the -1 power, which means the same as 1 over sine, which equals cosecant. Let me caution you. We can see in blue over the sine button, it says sine and then a -1 superscript. That does not mean the same as this. This means inverse sine or arc sine, which is completely different. So don't hit second sine and try to use that. You will get the wrong answer. So I believe the other equation, the right side, is 2. Here's y2 set equal to 0. Before we hit graph, we need to adjust the window. We are only looking for intersection points between 0 and 2 pi. So x min should be 0, and x max should be 2 pi. We can leave y min and y max as -10 and +10. So go ahead and hit graph. We see the one intersection point right here. Let's find it by hitting second trace and choosing option 5. Move the pointer close to the point of intersection and hit enter 3 times. Enter, enter, enter. And there it is. Always use 4 decimal places and don't try to round. Number 8. Let f of x equal 3.1 minus 1.2 secant of pi x over 6. In the xy plane, what are the x-coordinates of the points where f of x equals -3 between 0 and 2 pi? We will set f of x equal to -3 and solve by entering the left side of the equation as y1 and the right side of the equation as y2. Since there is no secant button, I will enter secant as 1 over cosine by entering cosine to the -1 power. So let's check the window again, but we already adjusted x min and x max to go from 0 to 2 pi. So as long as you didn't change that, you can go ahead and just hit graph. Here's the intersection point we are looking for. Second trace, option 5. Move the pointer close to the point of intersection. I don't see the pointer, so here's a pro tip. Hit the up or down arrow key. That moves the pointer to the red line, and it's really easy to move straight to the point of intersection. Hit enter 3 times. Enter, enter, enter. And there it is. Always use 4 decimal places and don't try to round. Number 9. Let f of x equal 3.5 times the cotangent of 0.51x. In the xy plane, what are the x-coordinates of the zeros of f of x between 0 and 2 pi? The zeros are where f of x is equal to 0. So let's enter the left side as y1 and let's enter the right side as y2. Since there is no cotangent button, I enter tangent, but I give it a -1 exponent. Since we already have the window set to 0 to 2 pi, we can just go ahead and hit graph. Here's the 0 that we are looking for. Let's find the intersection point by hitting second trace, option 5, move the pointer close to the point of intersection, and hit enter 3 times. Enter, enter, enter. Okay, I'm getting this error, and instead of just re-recording this part, I want to show you how to fix this error in case the same thing happens to you. So let's quit our way out of this and go back to the graph, and let's hit second trace, option 5. But this time we're going to move the pointer around a little bit. Let's make sure there is a sign change. So I'm going to leave my pointer a little bit to the left of the intersection point and hit enter. Now I'm going to move my pointer a little bit to the right of the intersection point and hit enter. Now I'm going to move back in between for the guess and hit enter. And this time I get an answer. Always use 4 decimal places and don't try to round. For number 10, we are given an expression for f of x, and we need to find where f of x is equal to 1. So let's enter the left side of the equation as y1 and the right side of the equation as y2. There is no cosecant button, so I'm going to enter sine and give it a -1 exponent. The window is already set to the interval between 0 and 2 pi, so let's go ahead and hit graph. Look, there are 2 intersection points this time. So let's be very careful. Second trace and option 5. Let's move the pointer. I'm jumping to the red line by hitting the up arrow key so I can move very quickly over to the first intersection point. I'm going to try simply hitting enter 3 times. Enter, enter, enter. So here's the first intersection. 4 decimals, don't try to round. Now let's find the other intersection point. Second trace, option 5. Slide on over to the other intersection point and hit enter 3 times. Enter, enter, enter. There it is. These are the x-coordinates of the 2 intersection points. For number 11, we are given this expression for f of x, and we need to find where f of x is equal to -5. So let's enter the left side of the equation as y1 and the right side as y2. Since there is no secant button, I will enter secant as 1 over cosine by typing in cosine first and then adding a -1 exponent. Looking at the window, make sure that your window has been adjusted to the interval between 0 and 2 pi. Then hit graph. So, looks like there's only 1 intersection point. Let's do second trace 5. And we need to move our pointer close to the point of intersection. Hit the up arrow key to make the pointer appear, and then move that close to the point of intersection, and hit enter 3 times. Enter, enter, enter. And there it is. Always use 4 decimal places and don't try to round. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.